Now, welcome in our fact lecture. Today, we are going to discuss switching converter type VAR generators, and the learning objectives of today's lecture are understand the switching converter type VAR generator, then identify the different method of switching type VAR generators, and summarize the static synchronous condenser, or we'll just write as a static synchronous condenser or compensator. So the combined name become Statcom. Statcom. This is very famous and versatile in the fact devices. So till date, we have seen different type of shunt compensation. That shunt compensation is comprising of inductor and capacitors. These shunt static VAR generators and compensators like thyristor controlled reactor, thyristor switch reactor, and thyristor switch capacitor, as well as there are some combination of capacitor and inductor like fixed capacitor, thyristor controlled reactor, or it may be a thyristor switched capacitor. Means there are a number of capacitors are there which is going to operate in step manner, and it is done some smooth variation or smooth control is a thyristor control reactor. So these are the static VAR compensator which comprises of inductor and capacitors, and it is going to switch, means the thyristor walls are going to switch synchronously with the system and simultaneous as per the number of thyristors, thyristors they are connected either in series and parallel. So it is simply we are connecting and disconnecting, or it may be some smooth control over the reactor as well as the capacitor to meet the required compensation in the transmission line. And it is possible to supply the controllable VAR or controllable reactive power. Either it may be absorption or either it may be a generation. Simply when we call as a VAR generation, it means that we are going to deliver the reactive power to the transmission line, and it is a capacitor. And whereas there is a absorptions are there. So under reactive power absorption, a reactor is connected or the reactor is going to use for that purpose. Now, we will try to understand what is the switching converter type VAR generation. In the variable impedance type, we are using capacitor and inductor for the VAR generation and absorption. Now it is possible to generate or absorb a reactive power from the transmission line without capacitor and reactor. And it is done with the help of the converter which is going to generate and absorb. So the first part is the switching type converter. Switching type converter. This converter may be DC to AC, or it is AC to AC with system frequency. So without using any inductor and capacitor, it is also possible to generate or absorb the reactive power from the transmission line or in the system. And the one more advantage that it also exchange the active power in the system. Okay, this is one thing. Second thing is that the switching converter type VAR generation, if it is utilize some storage energy, either it may be a charge capacitor, it may be a battery storage system or superconductors, conducting materials are there for the energy storage system, any type of energy storage system. It also deal in the active power output or active power supply to the transmission line and absorption from the transmission line. Now, since our ideal synchronous machine, say machine or motor, it also consume active power. It may deliver the reactive power under excitation, and it also deliver reactive power in the over excitation system, and under excitation system it consume the reactive power. So we can say that ideal synchronous machine or motor is a we can say that it is also a active compensation in the transmission line. Now, if same conditions or same say output or same function can be done with the help of static that is switching type converter, so then it is called as a static synchronous generator. Static synchronous generator, and it may be called as a SSGs, isn't it? So static synchronous generator is operated without any storage and with appropriate control to function the shunt connected reactive power. It is analogous or similar to the rotating synchronous condenser. So what it doing, as if the same means, what is the one is the reactive power generation, it may be the reactive power absorption. What is that? Say it is we are consuming the reactive we are delivering the reactive power, we are consuming the reactive power, and without storage, if it is done with the help of static that is the switching converter type, it is similar to the ideal static synchronous generator. So it is called as a SSG. Now, the operation of switching converter type VAR generator is similar and analogous to the synchronous condenser. The word is a synchronous condenser. What is that? Generally, we use synchronous motor overexcited synchronous motor acting as a synchronous condenser. So as the operation is similar to the synchronous condenser, but it is not rotating, whereas our synchronous motor or synchronous machine is a rotating one. If the same function can be obtained with the help of switching type converter, it become static synchronous condenser or compensator or condenser, and hence the short name of this one become Statcom. become a stat. So what is a Statcom? Statcom, ideally, it is a synchronous motor, or the function of synchronous motor and synchronous Statcom is similar. Only that in case of the synchronous motor, it has rotating part, whereas that rotating part is replaced by switching type converter. So it is replaced by the switching type converter, whereas the function of the switching type converter is similar to the under-excited and over-excited synchronous motor. Therefore, it is called as the combined name become a Statcom. Now, we try to understand the ideal operation of synchronous rotating type synchronous motor for the compensation. So it is a basic operating principle of Statcom. But we are using as a synchronous motor. Okay. Say it is synchronous motor. We will try. First, we will use as a synchronous motor its operation for the VAR compensation in the transmission line. So this is the transmission line. It is connected with some coupling transformer. Then leakage reactance of transformer as well as synchronous motor or synchronous machine, and it is excited with the help of some excitation system. Synchronous motor, it is excited. So this is the excitation circuit, because the synchronous motor is a double excited machine. It required the AC supply for the three-phase stator and DC supply on the rotor. It is a exciter. So the EMF induced or the back EMF of DC back EMF of synchronous motor is say E, whereas the reactance is X. It is the total reactance. It included the leakage reactance of transformer and synchronous reactance of synchronous motor, and the voltage of system or the transmission voltage is V. Now, the current may deliver or it may consume. Say, for example, here we have seen this is the current which is taken by the motor. So definitely when the motor consuming current, this current is a lagging one. So the value of current I is equal to, since it is from transmission line to the motor, so definitely voltage V is greater than the EMF induced or back EMF of the synchronous motor. Say it is a synchronous machine or motor is there, especially motor is there, and this is DC excitation. Let this is the current IF, and this is this one divided by the reactance. This is the current which is going to exchange between transmission line and machine. And the reactive power, either it is delivering or either it is consuming. which is equal to 1 minus E upon V divided by X into V. This is the reactance of the reactive power of the machine. Now, if the excitation is smaller, or we can say that if the excitation is less than normal excitation, the back EMF, so we'll take the conditions. Excitation below normal value. It means that back EMF is smaller than supply voltage. Under such condition, motor is going to work as a VAR absorption. Okay, it is going to absorb the reactive power, means it is taking the reactive power from the source. Second case, when excitation is above normal value, that is supply voltage or the system line voltage is the back EMF E is greater than supply voltage. So under such condition, it work on the lagging power factor. Say it is on the lagging power factor, and whereas it is going to work on the leading power factor, and it is going to generate reactive power. Whereas if the excitation is normal, third case is a normal excitation. Under such condition, back EMF is equal to the supply voltage. So machine neither delivering, neither consuming the reactive power, and just it is floating. So it is working at unity power factor. These things already we have learned in the machine, but here we are looking as a shunt compensation in the system. So this can be explained with the help of V curve and inverted V curve, or it may be the variation of excitation with respect to the variation of armature current with respect to the field current, keeping the load constant. The load is either it is a no load condition for generating. Say this is your armature current, and the power factor is there of the motor, and here is the field current, DC field current is the excitation system, or current is there. We found that the curve is like a V curve. So this part is a normal excitation. Here it is a normal excitation, whereas it is the over excitation, and it is under excitation. In under excitation, the power factor become lagging. So say this is the power factor, this is the armature current IA, and this is the power factor. So under such condition, the power factor is leading, this power factor is lagging. So it is quite clear, if any machine it is going to work on the lagging power factor, it consumes the reactive power, and when it is working on leading power factor, it consume leading current, and supply the reactive power. So suppose this is the points over which we can represent. This is the VAR generation. VAR generation, and here it is VAR absorption. So up to this one, at this point, it is just floating, neither consuming nor generating the reactive power. Okay, so we can obtain smooth control or smooth variation of the reactive power with the help of rotating synchronous machine. But the disadvantage is that it consumes the active power. We have to give attention toward the maintenance because it is a rotating machine. So we want to replace it by a static one. So static, some combination of static circuit plus the operation or the characteristic of the synchronous motor or synchronous condenser combinedly become a Statcom, or it is simply switching converter type VAR generation and absorption. So what would be the circuit? It is similar to the system which explained in the synchronous machine, synchronous motor over this one. So now this is the system voltage or line voltage. Line voltage, then there is a coupling transformer similar to that one, coupling transformer, and leakage reactance. So it is a coupling transformer. Leakage reactance X is there. It is due to the transformer leakage reactance. Now it is connected with the switching converter. Switching converter. Okay, so it is switching converter. It may be a DC to AC switching converter, or it may be a, so generally it is we are using DC to AC switching converters is there, and this is one charge capacitor. Okay, so it is therefore it is a DC to AC converters. Now in this case, there are two types. The converters may be a voltage source converter, and second is the current source converter. In current source converters, external protection is needed when it is connected to the transmission line, whereas in the voltage source converter, since the system is connected with the voltage source converter, we does not require any additional protection devices. So in practice, voltage source converters are preferred. Whatever the number of Statcom has been installed, it is a voltage source converter. So we will discuss only the voltage source converter. Now look at this figure. It is analogous to the synchronous machine connected to the transmission line under overexcitation or as a condenser. It is a coupling transformer, reactance, and this is switching converter is there. Instead of the synchronous machine is the switching converter. Now, all these parts are a static one. It does not require any external capacitor and inductor. This inductor is the leakage reactance of the transformer. It is not a like an inductor, external inductance has been connected. It is only the leakage reactance of the transformer. Therefore, we can say that it is a static synchronous condenser, and the name become a Statcom. So this is one similar to this one. In the next lecture, we will see the detailed operation of Statcom along with its VI characteristic and or the area of operation for the Statcom or static VAR compensation.